Here, first question asks how many 5-digit numbers can be formed using 6 given digits. So in schools, we learned it as NPR. Out of 6, we need to choose 5 and arrange them. So 6P5, which will be 6 factorial, divided by 6 minus 5 factorial. Let's write that one down. 6 factorial divided by 6 minus 5 factorial. So that will give you 6 factorial. That is 720. 6 minus 5 factorial is just 1 factorial. That's how it's 6 factorial self, and then 720. This is one way of looking at it. Other way of looking at it is there are 5 vacancies and there are 6 numbers, digits possible. How many ways can we do it? So we start with 6 slots and fill each one of them. First slot can be filled by any of the 6 digits, and the next one 5, 4, 3 and 2. That again gives you 720. Now let's go to the second question. Second question asks how many of these numbers, that is out of the 720, how many of them are not divisible by 5? Let's do it this way. It's easy to handle numbers which are divisible by 5. The condition is either the unit digit must be 0 or the unit digit must be 5. So consider numbers which are divisible by 5. In order for us to do this, let's start with filling the last position. The unit position is filled by only one item. It has to be the 5. We are looking at how many ways this is divisible by 5. So unit position is filled by 5, one way, and any of the other position, when we go there are 6 of them. 5 remaining ones are there. So 5 ways, 4 ways, 3 ways and 2 ways. All put together, this will give us 120. So out of 720, 120 of them are divisible by 5. And question asks how many of them are not divisible by 5. It's just simple subtraction. 720 minus 120, 600. Let's go to the third question. How many of these numbers found in part 1 are even and greater than 30,000? So there are 2 things important here. One has to be even. The other one is it has to be greater than 30,000. A 5-digit number should be greater than 30,000. Now the complication is, it does matter whether we fill with a 2 in the unit position or an 8 in the unit position, because when you come to the 10,000s position, it will be less. There will be less options to fill it if you had already used an 8 on the right side. So let us break it down. Let us consider numbers greater than 30,000 which are even, such that it ends in 8. So let's break it down. So numbers which must be greater than and even and end in 8. So let's start with the last position or units position. It can be filled in one way. It has to be that 8 itself that we will be using here. Now the second one that you need to fill is the unit position. After 8 being used there are 3 ways to fill this position. Those are, let's go back to the numbers, 3, 5 and 7. There are 3 ways to fill this. After that, there are out of 6, 2 of them are used. There are 4 remaining ones. 4, 3, 2 ways we can fill all of them, and that is 72. The second situation that we need to consider is greater than 30,000 for sure, and it ends in 2 this time. So let's break it down, that one, and analyze it. This time it has to end in 2. So in order for us to do it, as usual, we start with 5 slots and let's start filling the last position. Last position can be filled by only that 2. So there is one way to fill the last position. Immediately after that, we should go fill the first position. It can be filled by this time 8, 7. There are 8, 7, 5 and 3. Those are the possibilities. And then 4, 3, 2, 1 as we did earlier. And this will give us 96. So there are 96 ways you can start with a number greater, we can have an even number ending in 2, and that number must be greater than 30,000. There are 96 ways. So when we accumulate these two, that will give us 72 plus 96, 168. So 168 ways we can have this. Let's go to the last question. It says number of combinations of n taken 3 at a time. So this is NC3 or NC3, and question says that is 6 times number of combinations of n taken 2 at a time. So this is 6 times NC2. Formula for NCR is n factorial divided by n minus 3 factorial multiplied by 3 factorial. That is equated with 6 times n factorial divided by n minus 2 factorial and 2 factorial. Let's cancel out the terms. On the left and right side there is n factorial. We can cancel them out, and 6 and 2 factorial can get cancelled out. You have a 3. Now what we have remaining is interesting. There is 3 factorial n minus 3 factorial, which is equal to the remaining. So let me write that one down. In this, we could further simplify. 4 factorial is 4, 3, 2, 1, all of them multiplied together. It is same as 4 times 3 factorial. Using that idea, let us further simplify this. Instead of n minus 2 factorial, we could rewrite it as n minus 2 multiplied by n minus 3 factorial, as we have seen earlier. Okay, now in this, cancel out n minus 3 and n minus 3 factorial, n minus 3 factorial and n minus 3 factorial, and that will give us n minus 2 is equal to 18, which is same as n is equal to 20. I hope this helps. All the best.